Okay, sorry for that. Responding to something I sent here. Okay, are we there? Or am I speaking to myself? Kindly let me know whether you're there. Are you in the meeting? Okay, Linus is present. Who else is present? Rosemary, yes. Albert from Bua. Let's get some more feedback. Caris, we are still here. Okay, thank you so much for yes. Boya, Ninka, have your full name, kindly. And Caris, kindly have your full name appearing there. Thank you. So OSPF version 3. Now this one operates based on links. Semi-evil, right? Yeah. This one operates based on the links, not the network segment. OSPF version 2 works or rather operates based on the network segment. Okay, OSPF version 2 is here, operates based on the network segment. Okay, yeah. But now for OSPF version 3, here we run the OSPF between the links, right? This link here. Okay, yeah. So when you're configuring OSPF on a router, you configure the configurations on the link. You select that interface, then you configure OSPF there. Okay. So for instance, for example, we have gigabit 0/0/1 on router 1 here, and gigabit 0/0/1 on router 2. Okay, so we established these two interfaces when they're configured with IPv6 addresses. You can see this is a global unicast address, another global unicast IPv6 address. Allow me to control some noise around here. All right. Sorry for that. Okay, so we said we establish adjacency. For example, we said that IPv6 comes with some unique features. One of the features is that it has that automatic neighbor discovery capability, right? There's a capability to discover neighbors. Okay, so even before you even think of configuring OSPF, router one and router two already are aware of each other. Okay, in other words, they establish neighbor relationship. So when OSPF version 3 is running, two neighbors now only need to be on the same direct link. So it becomes very easy to set up. That's why I've said OSPF version 3 networks and OSPF version 2 have that difference in that OSPF version 3 is kind of easy to set up and very much convenient to work with as compared to OSPF version 2. Okay. Now, we have mentioned something that OSPF version 3 supports multiple or the multi-instance working. In other words, it supports what we call dual kind of operations on the same link. So the same link, you have multiple instances. Okay, you can bind multiple instances to the same interface. So a single physical link can run multiple OSPF version 3 instances. Okay, so that's an advantage in OSPF version 3 compared to that of OSPF version 2. So in OSPF version 1, we can only have one OSPF version 2 instance in a given physical link. Now, these OSPF version 3 instances can establish neighbor relationship with other neighboring devices at the remote end. So they will send packets to the remote device, and they do not interfere with each other. Therefore, they can fully share the resources of the same link. Okay. So, for instance, between this router 1, assuming we have a switch in between, and router 4, we can actually configure multiple instances on each of these interfaces and ensure that they are communicating with each other without interference. Okay, so how do we differentiate the different instances? We use instance IDs. So when you're configuring an OSPF instance, you specify the instance ID. Okay, you specify the instance ID. For instance, allow me to get something for you. Let me open this lab. Instance IDs. For instance, I hope you can see clearly here. Let me zoom out. So we have what we call instance IDs. For example, when you're configuring OSPF version 3, you can look at this one. You start with the command OSPF version 3. The instance ID is this value here. Okay. So you can have one, you can create one instance. So this instance is what we are referring to. So you can set up another instance, number 2, and then bind them. You can have 3 instances, and then you bind them to the same physical port. For example, you bind it on gigabit 0/0/0 of a router. Okay, so the 3 OSPF instances can be bound to the same physical interface. That's what we are referring to in this concept here. So we separate the instances with instance IDs. So two OSPF version 3 instances, for example, 1 and 2, can be created on each of router 7, example, and 8. And 2 instances of the same link can be activated on the same. Now, let's look at OSPF version 3 LSA types. OSPF version 3 LSA, link state advertisement types. So compared to OSPF version 2, OSPF version 3 LSAs have a similar kind of nomenclature or rather names, but they're slightly different in function, right? The operation they work. So the names kind of resemble, but the functioning is different. And then something else is that OSPF version 3 introduces two new types of LSS. One of those LSS is what we call the link LSA, which is type 8, and the intra-area prefix LSA, which is type 9. Okay, so here we're introducing 8 and 9. So we have 8 and LSAs. So we're going to be discussing them shortly, but before them, let's look at the common ones. So we have the router LSA, network summary LSA. This is for OSPF version 2, right? Yeah. So we're going to relate the LSS in OSPF version 2 with the LSS in OSPF version 3. So router LSA and network LSA, they function similarly in the two versions or the OSPF versions. In that, router LSAs, these are LSAs which are generated by every router. Okay, yeah, they describe things like cost, the link, and other things like router ID and etc. etc. Network LSAs, these ones are generated by designated routers in a broadcast network. So we have designated routers in a broadcast network. They are the ones which generate the network LSA. Now, the difference between OSP version 2 and version 3 router LSAs and network LSA is that for OSP version 3, here we do not carry the IPv6 prefixes. Someone is asking what are IPv6 version 6 prefixes. These are addresses, right? The address information. So you have no IPv6 prefixes. But in this side, we carry IPs there. IP addresses are carried in these two types of LSAs. Then we have type 3 LSA. Type 3 LSA, in OSPF version 2, we refer to it as network summary LSA. And we say this guy is generated by an ABR, area border router. What does an ABR, what does a network summary LSA do? It is used to assist in inter-area routing within an OSPF domain. So it's used to generate routes from one area which needs to be advertised in another area. So it is used now for inter-area route transfer. We refer to that LSA as network summary LSA for OSPF version 2. Now, when it comes to OSPF version 3, we give it another name, inter-area prefix LSA. This one is very easy to understand, right? As compared to the OSPF version 2. We call it inter-area. So meaning this is something that is happening between areas, and which device is responsible for managing inter-area communication and area border router. So the functions are the same, but the names are different. So in the area, LSAs are generated by an ABR, and they are used for inter-area communication. Now we have another type 4 LSA, which you refer to ASBR summary LSA, which is found on ABR, or rather, which is generated by areas, ABRs. ABRs are also the ones that generate type 4. It describes the routes to the ASBR. It is used to inform the backbone area on how to access the ASBR router. So in IPv6, that is in OSPF version 3, we refer to it as inter-area router LSA, Okay, so it's used now to point to the ASBR. You have said an ASBR is a router that sits between two different autonomous systems. Then you have type 5. Now, these two guys are generated by ASBRs, Autonomous System Border Router. Okay, so the first one, that is AS, external LSA, which is found on OSPF version 2, relates with a similar one in OSPF version 3 in terms of name. They have the same name. We refer to it as AS external LSA. AS external LSA. And then we have the not so stubby area LSA, which is type 7, is also referred to as the not so stubby area LSA. And these two guys have the same similar kind of function, but they are used differently on an OSPF network. So for instance, type 5, we have said these are LSAs which describe the routes to the routes to destinations outside the autonomous system. And so is not so stubby area LSA. These are LSAs that also describe the routes outside of an autonomous system. But you have said they are used differently in that type 7 LSAs are not allowed in the backbone area. Okay. Yeah. So when they are being transmitted to the backbone area, the ABR converts these type 7 LSAs into type 5 LSAs and injects them into the backbone area. So remember, I've said they function similarly, but they are used differently. They're used in different areas. That's the word. Then we have type 8 and type 9. So type 8, they are known as link LSAs. So in OSPF version 2, we do not have type 8 and 9. Okay. They come in the OSPF version 3. So we have type 8, which is known as link LSA, and these ones are used now to advertise the link information. And then we have the intra-area prefix LSA. Okay, yeah, these are new. We are going to discuss them shortly. So before we discuss them, I would like us to take a break. We can have our break today at 10, and we can resume at what time? What time do we resume? Let's agree. Or maybe let's agree to disagree. 10 that is fine now. Let's be back. Hello. Okay. Sorry, I was touching my mic. I can see here. Okay. Let's look at now the new LSA types that we have. I hope you can hear me. Confirm you can hear me. Okay. Thank you. So let's look at uh, the new terms here. So we have the inter-area prefix LSA. Now this one you have said is similar to the network summary LSA. Remember, network summary LSA is uh, the LSA that is generated by an ABR. So it's used now to process inter-area communication between different areas, right? We refer to it as network summary LSA. Okay, so sorry, it's similar to network summary LSA in OSPF version 2. So it serves the same purpose in that it's generated by an ABR to describe routes within the IPv6 address prefix in a given area. Okay, yeah. We're not going to look at details. That's not important for now. And then we have the inter-area router LSA. So there's the word router here in the middle. And for this other one, it's a prefix. Okay, yeah. So this one is used to describe the routes to the ASB. routes that are outside of the autonomous system. So when type 7 are flooded in this area, and this router needs to inform the backbone about type 7 routes or the LSS, then those type 7 LSS are converted into type 5s, and that's why you have a type 5 here. So these type 5s are used now to enable the backbone, which is a transit area, to communicate with the areas that are outside of the autonomous operating system. So to configure a total stub on the ABR, so we do it on the ABR. So you want to specify this as a total stub, you configure the ABR. So you go to the OSPF process of the ABR, then you say stub no summary command. Hope that is clear. Now let's look at problems in the stub area and total stub area. So as defined in OSPF, the stub area cannot import external routes. You have seen that one, okay? Stub areas, we do not have type 5 there. Okay, yeah. And we'll see the total stub area, we do not have type 4 and 5. So this mechanism prevents a large number of external routes from consuming resources in devices in the stub area. So remember, stub area is only done, especially when you have low-end routers, and you do not want to overwhelm them with external routes. You configure it as a stub. For instance, assuming this is a server here, and is connected to this route here as an external network. Okay, so you can prevent these routes from crossing to other areas, okay, of your network by preventing type 4 and 5 LSS. Now, stub and total stub areas cannot apply to scenarios where external routes need to be imported. So there are scenarios, different networking scenarios where you are expected to access the external routes directly. So stub is not ideal for that kind of network deployment. Now let's look at other types of special areas. We have what we call the not so stubby area. Not so stubby area. Not so stubby area. Now this is an area that is a stub, yes, but not so stubby area, meaning this is an area that can import external routes, but cannot learn external routes. Well, you can import them, but you cannot learn from other areas, from other imported routes in other areas. Assuming we import routes to this side, we have informed this server, this route about this server. So these routes are not going to be imported here. Okay, yeah, not possible. Okay, so this is a area where you can import external routes, but you cannot LAN directly. We refer to that part of the network as not so stubby area. We have what we call a totally not so stubby area. So the difference between the totally not stubby area and the no so stubby area is that the no summary command is specified on the ABR for the totally no so stubby area. Okay. Let's look at the LSDBs of a not so stubby area. So we said in the not so stubby area, we configure the ABR. In this case, our ABR is this router. We configure it with this command, NSSI. So you display the LSDB of router 3, sorry, of router 5 here, which is a ASBR. You'll be able to see that we have type 7 LSAs that are showing there. And also the type 3 LSAs, which are the network summary LSAs. Now for a totally not so stubby area, we have said that we configure the not so stubby area with no summary command or the no summary keyword. So that way we are able now to ensure that we can import external routes while still maintaining the inter-area communication. So this is an example of what I was trying to put across. So in a total stub, we have type 1 and type 3 only. There's no type 4 or type 5. In the backbone, we have type 1, type 3, type 5. I want to ask a question. I'll say, you can see here, I've just indicated type 1, type 3, and type 5 in the backbone area. Okay? Yeah. So this one applies to which type of network? We have two answers. A, broadcast. B, point to point. Anyone who can try? I want to see whether you're understanding this concept. Linus has answered. Let's get some more feedback. Victor. Okay, we are getting more feedback. Thank you guys for the attempts. Let's get some ladies. Ladies, where are the ladies? I just want to know the names. If you answer, I'm getting also to know you by name. Where are the ladies? Phyllis is there. Phyllis Nassimi. I know Phyllis Nassimi. We'll get to interact very soon. We'll be having the awarding ceremony, so I'm sure everyone will be there. Let's try to catch up and get to know each other more. We there. Okay. No one else wants to show them names. Okay. So the answer is point to point. Right? Yeah. The answer is point to point. Remember, in broadcast, we said we have type 2. Okay. Yeah. In broadcast, we have type 2, which are known as network LSAs. So network LSAs are usually generated by, so type 2, sorry, type 2 LSAs are generated by the DR, the designated router. Okay, yeah, the designated router is a device that is elect on a broadcast network, or a broadcast multi-access network, with the aim of controlling adjacencies within the OSPF domain. Okay, so if you don't see type 2, that means it's a point to point, right? So in a point to point network, we do not have type 2. Otherwise, if you find, so if these routers were connected in a broadcast network, OSPF network, then type 2 will also be appearing there. I hope you have understood. Okay, yeah. Okay, yeah. So they'll be asking logic they'll be testing to see your logic, whether you can be able to deduce and understand some of these, whether you have understood these concepts. Okay, yeah. Now, there are other areas that have not been defined as stub or not so stubby areas. So in those areas, you can receive type 4s and type 5s there. Okay, yeah. In other words, what I was talking of here at the backbone, you can also have type 2 LSS if the network type is broadcast. But I think I decided to put type 1, 3, and 5 because the best practice for a large network is you use a point to point so that you'll eliminate the need for electing a designated router. Because designated routers also come with their own fair share of problems. That when the network changes a little bit, or maybe there is network flapping, the routers may assume that the designated router is unavailable and they will start triggering elections. Though there is no preemption, okay? So it will have an impact. So point to point is for networks that, for designs, or the OSPF network designs that you intend not to have many interruptions. Okay. We have said the total not so stable area will have type 1, type 3, and type 7. Okay. You can also have type 2 there if the network is broadcast. Right? Yeah. So there we do not have type 4 and type 5. So when we've learned type 7 LSS, which I've said are known as the not so stable area LSS, which describes the routes to the external networks which are outside of the autonomous system. So type 7 LSS, as they're being sent to the backbone, they'll be sent as type 5. So the ABR will convert type 7 into type 5 as they're being forwarded to the backbone area. Okay, hope that is clear. Now let's talk of route summarization on an ABR. So we said route summarization is a process of bundling, let me use that bundling specific routes into a summarized route. So routes before summarization, they are known as specific routes or refined routes. When they're summarized, we call them summarized routes. We did cover yesterday something on route summarization. Okay, and I gave you the formula of or rather how I showed you how we summarize routes. So OSPF route summarization can happen on an ABR or on an ASBR. So on an ABR, inter-areas routes can be summarized. What do we mean by inter-area routes? These are routes from different areas. Say, for example, area 1 and area 0. Okay, yeah, so we can summarize these routes at the ABR. We can also summarize external routes. External routes are learned where? On an ASBR, Autonomous System Border Router. Okay, so you perform your summarization. Assume you have these networks here. So when you're configuring your ASBR configurations, you say ABR summary, then you specify, you put in the summarized route and the mask length. Okay, yeah, I showed you how we summarize routes. So after you summarize all these networks, you put the resulting summarized route and the World Cup. Sorry, not World Cup, but and the mask length. So after route summarization, for example, here router 2, which is an ABR, will advertise only the summarized route. Okay, so after we have summarized all this, so router 2 is only going to send that summarized route to area 0. So this one helps us to reduce the size of the routing table. We have said that route summarization can also take place on an autonomous system border router. So after route summarization is configured as ASBR, so we configure it this way. We get to the OSPF process of an ASBR, then we say ASBR summary, then we specify the summarized route and the mask length of that summarized route. So in a not so stable area, NSA network where we find the ASBR, the ABR will translate type 7 LSS into type 5. We have said that. So ASBR, assuming this is the ASBR, will change, or rather will generate type 7 LSS and flood them in this area. So once these LSS get to router 3 is going to change the not so stable area LSS, which are known as type 7 LSS, into type 5 LSS, which are known as external LSS. Then it will inject them into the backbone area. Okay. Now let's look at other terms that are also found in OSPF. One of those terms is silent interface. Silent interface. Now there are interfaces on your network that should be silent in that they should not be participating in any matters to do with OSPF negotiations. So for instance, you have a server that is connected to a router here, a router that is configured for OSPF. Okay? So a silent interface is that interface that should not be involved in receiving OSPF low packets, or maybe receiving OSPF packets. We also have other packets that are used in the working or in the operations of the OSPF protocol. Okay, so for you to do that, you can identify these interfaces as what we call silent interfaces. Silent interfaces. So this can enhance the networking adaptability of OSPF and reduce system resource consumption. Okay. So this interface here, you can say OSPF, that then it specifies silent interface is gigabit Ethernet 0/0/1. This interface will not be participating in matters OSPF negotiations or the communication. Now, the other concepts that we're going to look at is OSPF packet authentication. OSPF packet authentication. So OSPF packets can be authenticated. And we have two ways in which we can authenticate OSPF packets. One is by authenticating the area, and that's what we call area authentication. So this authentication mode uses a password on all routers that belong to the same area. So the routers in the same area have to utilize the same password, okay, for them to be able to communicate with each other. We can also implement OSPF authentication on the interfaces. Okay, so the authentication mode and password of the interfaces refer to the directly connected neighbor interfaces. So two neighboring interfaces or the two neighboring routers should configure the same password on the interfaces that are adjacent to, or rather that are connected to each other. Okay. So we have interface authentication and area authentication. Interface and area authentication. So we have two types of OSPF authentication. We have plain text, plain text. Plain text means there is no password. Just one easy way of saying, or the password is encrypted. Sorry, it doesn't mean there is no password. It means that the password is not encrypted. Okay, yeah. And then we have the message digest version 5. We call it MD5. Okay, yeah. So let's answer these two questions. Yeah, three questions. Sorry. Precise. We are told number one is a multiple choice question. Which of the following special areas are defined by OSPF? Special areas. We have stub area, totally stub area, not so stubby area, and totally stub. Yes, all of them are special areas that are defined by OSPF. Question number two, we are told what is the difference between a stub area and a totally stub area? We are saying that a stub area does not allow type 4 and type 5. No type 4 and type 5. Okay, so in a stub, no type 5, sorry, no type 4 and type 5. But it allows type 3. Okay, yeah, so we use type 3 as the default route to forward packets to other packets. So a totally stub, on the other side, a totally stub area does not allow type 4 and type 5 or type 3. Okay, so here no 4, sorry, no type 3, 4, and 5. So totally tab, we have said, does not allow type 4 and type 5 or type 3 LSS. Let's look at question 3. Which router is configured with the inter-area route summarization function? Inter-area means different areas within the same OSPF domain. So in that case, it's which router? ABR. Yeah, ABR. Thank you, Maria. It's an ABR. It performs the inter-area route summarization. So this brings us to the end of this topic. It was an interesting topic. That is OSPF basics. The lengthy topic. We'll discuss more in details about this topic when we meet for the regional finals preparations. Okay, next year. Yeah. Now let's look at ISIS. ISIS is another similar protocol, which is also an IGP, integrated protocol. So ISIS is an integrated protocol, which is also link state, whether it shares, whether it works based on the link state advertisements. So this one also works similarly to OSPF. But in terms of the system overhead, what do I mean by system overhead? In terms of the amount of memory and processor resources that it requires compared to previous ISIS. So ISIS is used in larger networks. It's ideal for network, okay, as compared to OSPF. So OSPF you can use on a small network. ISIS you can use it to a slightly larger network. For example, an ISP backbone network. So to support the ISP backbone network, we can use ISIS. It's a good protocol. ISIS compared to OSPF is that ISIS works both in the data link layer and network layer. So ISIS works at these two layers, data link layer and network layer. Okay. Let's have an overview. Yeah, we have said it works at both these two layers. It resides there. So it comes with the concepts which helps us in providing that flexibility. Okay, so we normally call it connectionless networking. So ISIS is a connectionless network service, connectionless network service in the OSI protocol stack. Okay, it's a connectionless and IP. So it applies to both connectionless and also internet protocol networks. ISIS packets are usually encapsulated in frames. Of the data link layer. Okay, so compared to OSPF, OSPF applies only to IP networks. ISIS applies to both connectionless and IP networks. Another thing about the packet structure is that OSPF packets are encapsulated in IP packets. I hope that is informative. So we have another term that is used in ISIS we call network service access point. Network service access point. So this one is an address which is defined to assist ISIS protocol to locate resources within the ISIS domain. So it provides interfaces between the network layer and the upper layer applications like transport layer. The network service access point is composed of two areas, another two things. One is known as the initial domain part, and the other one is known as the domain specific part. The initial domain part is something that is similar to a network address in IPv4. Okay. Yeah. So the network address is something that correlates with the initial domain part of the network service access point. And the second part is known as the domain specific port. Now, the domain specific port, consider it as something that's similar to the subnet mask. Okay. So we have the IDP and the DSP. So the IDP, we said, is similar to the network ID of an IP address, and it indicates the address allocation authority and the address format and other features. The domain specific refers to the I-ordered BSP or that's BSP that is comprised of values that are used now to describe uh, or rather to give details of the particular entity within an ISIS network. Okay, so to divide the ISIS network into various areas, we use now the DSP. So the DSP has several components. We have the I-order DSP, that is the domain specific part, and we have what we call the system ID, and we have what we call the selector, the network service access point selector. Okay. Yeah. So it is used to provide now the area division. We're going to see that shortly. Okay. So when we have said ISIS has a similar functioning, or they operate similarly to OSPF. So for us to subdivide an ISIS network into smaller areas, we employ these parts, okay, that we are calling the DSP. So we have the system ID, we have the I-order DSP, we have the system ID and cell. So these three fields constitute the area ID. Okay. Yeah, we're going to be using them to determine the NSAP. We have another uh, uh, term we call the network entity title. Network entity title. This one indicates the network layer information. We have said ISIS in two layers. We have the data link layer and the network layer. So the net indicates now the network layer information on ISIS and consists of an area ID and a system ID. So it is used especially during route calculations. So net can be considered as a special NSAP. That is a special network service access point. And it has a cell of 00. Okay. So cell here is going to maintain the value 00. So the length of a net field is the same as that of an NSAP. So its maximum length is 20 bytes and the minimum length is 8 bytes. So when running ISIS on IP network, you only need to configure network entity titles on devices. And these devices can obtain the area IDs and system IDs based on the network entity types. So the network entity type looks like something like this. Okay. So we have the system ID, which I said constitutes the component of the net. Sorry, we have the system ID and the area ID. For instance, here we have the area ID as 49001. The system ID is this value. The last one is cell. So this system ID, this is cell, this is area ID. I hope that is clear. So every network, that is every ISIS network, must have at least one network entity title. So a device can be configured with multiple nets, but the system IDs of these nets must be the same. Okay. So let's look at the differences between ISIS and OSPF in terms of area division. The differences become in terms of area division. So we saw that for OSPF, areas are divided based on the interfaces that belong to these areas. So in OSPF, we said the interfaces are where we based our area division. Okay. Yeah, for instance, a router can belong to multiple areas. Why? Because if, say, for example, we have a backbone area, that router will have some interfaces or maybe an interface facing the backbone area. And it will have another interface facing another area, say area 1. Okay. So, unlike compared to ISIS, ISIS takes up the entire device, or rather the entire router, and puts it in a particular area. So in OSPF, we pick the interfaces and we assign them to areas. In ISIS, we pick the entire system, or rather the entire router, and we assign it to a given area. ISIS routers are usually classified into 3 types. ISIS routers are usually they are classified into 3. We have what we call level 1 routers. Level 1 routers. Now, level 1 routers are routers which are deployed in the non-backbone areas. These are routers which are deployed in the non-backbone areas. And then we have level 1, 2, that is level 1, 2, and level 2 routers. So we have level 2 and level 1, 2 routers. These ones are deployed in backbone area. So level 1 is in the non-backbone. Level 2 and level 1, 2 are deployed in the backbone area. So each non-backbone area connects to the backbone area through a level 1, 2. So a level 1, for example, we have a level 1 here. So for this level 1 to communicate with a level 2, it has to connect through a level 1, 2. Okay. Yeah. So we have these 3 types of routers: level 1, level 1, 2 routers, and level 2 routers. Now, the difference in their working is that level 1 routers maintain level 1 LSDPs. So the link state database for level 1 can only be accessed by another level 1. Okay? Yeah. For level 1, 2, a level 1, 2 router, router is a router that maintains the level 1 LSDBs and level 2's LSDB. So a level 1, 2 router is a router that maintains level 1 LSDBs and level 2 LSDBs. But that router is a level 1, 2. So anytime level 1 routers are communicating with level 2 routers, communication has to pass through level 1, 2, and vice versa. So I've explained this. So we have level 1 routers. So for example, in this diagram here, we have level 1 routers here. So remember, a level 1 router can communicate with a level 2 router through a level 1, 2. You can see level 1, 2. So this is a non-backbone area. We say level 1 routers are used in the non-backbone areas. So you configure an area ID in that area, that non-backbone area. Configure a network ID, and then use the system ID and the cell, which is 00, to generate the net. Okay, yeah. So level 1 twos on the non-backbone areas are connected with level 1 2. You can also have another level 1 2 here if you want on the backbone area. Okay, for purposes of exchange of traffic. Or you can just have one router serving as level 1 2. So a level 1 2, we have said, is a router that maintains level 1 LSDBs and level 2 LSDBs. And level 2 routers, we have said these ones are used in the backbone area. This one can establish neighbor relationship with other level 2 routers or other level 1 2 routers. Okay. Yeah. Remember that a level 2 router does not establish neighbor relationship with level 1. Okay. Let's look at network types that are supported by ISIS. So ISIS supports two network types. We have what we call broadcast network and point-to-point. Okay. So at the data link layer, broadcast is defined by the Ethernet protocol. So the underlying layer 2 or data link layer protocol is Ethernet. At point to point, the data link layer protocol is point to point or high level data link control protocol. Okay, so the underlying layer 2 protocol defines now the type of ISIS network that is going to be realized. ISIS also has another concept we call cost. But now cost here is different. It's treated differently from OSPF. In OSPF, we said by default, OSPF cost is the link bandwidth. Okay. And by default, what is the default OSPF cost? Oh, sorry, before we get there, what's the default OSPF bandwidth reference or the reference bandwidth? What is the default reference bandwidth for OSPF? Anyone? What is the default reference bandwidth for OSPF? Anyone? This one might be one of those lunch questions. What is the default bandwidth reference for OSPF? 1, 2, 3. Okay, Emmanuel got it. So it's 100 Mbps. Okay, yeah, 100 Mbps. It's a default bandwidth reference in OSPF. Now, unlike OSPF, the cost of an ISIS enabled interface is not related to bandwidth by default. Okay, yeah, so it's not bandwidth by default. Okay, yeah. So in actual deployment, ISIS can adjust the cost based on the interface bandwidth. By default, the ISIS cost of any interface is 10, regardless of the interface bandwidth. Allow me to pick a call. Okay, so by default, the ISIS cost is 10 regardless of the interface bandwidth. So the cost of ISIS path is the sum of the cost of all links from the local router to the destination segment. So by default, cost is 10. Cost is 10 by default. Now, the cost of ISIS interfaces can be determined by the following modes in descending order. So we have the interface cost, which is configured on specific interface. We also have the global cost, and then we have the automatically calculated cost. So this is the cost that is automatically calculated on the interface bandwidth. Okay, so we are saying bandwidth is not the default parameter or the default factor for ISIS interfaces or the ISIS cost. Okay. Now let's look at ISIS packet types. Packet types. So ISIS during ISIS neighbor relationship establishment and neighbor adjacency, we involve these three types of packets. One is known as the ISIS LO PDUs. Okay, we call it the ISIS, that is intermediate system to intermediate system LO. And these are used to set up and maintain neighbor relationships. So among them, we have level one local area network IIH, which apply to level one routers on broadcast local area networks. Then we have level two LAN IIH, which apply to level two routers on broadcast local area networks. And we have point-to-point IIH, which apply to non-broadcast networks like point-to-point. So when you're reading revising IIH, that is a intermediate system to intermediate system LO packets. Know that there are some that are used for broadcast networks and others that are used for non-broadcast networks like point-to-point. The other type of packet that we found here, we call them LSPs. We call them link state PDUs. Okay. So link state PDUs, these are used to exchange link state information. And we have two types. We have two types of link state PDUs. We have level one LSPs and level two LSPs. Then the third type of packet is called a sequence number PDU. So this one describes all or some databases to help in synchronizing and maintaining LSDBs. So sequence number PDUs are classified in sorry, I hit the wrong button. Sorry. So sequence number PDUs, we are saying they are classified into complete sequence number PDUs and partial sequence number PDUs. So the complete sequence number PDUs and partial sequence number PDUs come in these flavors. We have level one, complete sequence number PDUs, and level two, complete sequence number PDUs. And we also have level one, partial sequence number PDUs, and level two, partial sequence number PDUs. Okay, so these are the packet types you need to be aware of. Now, the beauty about ISIS compared to that of compared to OSPF is that it comes with more flexibility and scalability in terms of packet construction. So we have to compare the OSPF packet to that of an ISIS packet. The ISIS packet has additional features which are built for flexibility and scalability. Okay, and we call these features type length value fields. So these ones are used to add more features into the ISIS packet structure. And that's why we have said ISIS is ideal for a large network compared to OSPF. OSPF will be ideal for a small network, but if you have a large network, ISIS comes in better. Okay, in that it has TLV values. You can modify the packets to carry more or maybe carry additional information. Okay, yeah, so we call these fields type length values. So TLVs, they feature high scalability and high flexibility in packets construction. Okay, so assuming you'd like to add information like IP internal reachability information. So you can have a TLB value number 128, okay, which will be used now to, which will be carried as an LSP, link state PDU, to inform neighbors on how they can reach the internal network. And then we have others like TLV number 130. We are just going to look at the ones that are popular. We're not going to mention all of them. Will be used and sent as a link state PDU. So the PDU type will be a link state PDU. And they'll be informing neighbors, ISIS neighbors, on how they can reach the external network. Okay. And then we have number 132 TLVs, which are used to carry additional information about IP addresses. So they're usually sent using the intermediate system to intermediate system LO packets and the link state PDUs. So they will carry additional information about the IPs that are being used for communication. So to add a new feature to the ISIS packet, what we do is that we add a new TLV without having to change the overall structure of the packet. Okay, so I hope you understood what a TLV is. So let's look at the rules for establishing ISIS neighbor relationships. Another neighbor relationship setup. So one of the rules is that only neighboring routers of the same level, need to know that, same level, can set up neighbor relationship with each other. For instance, level 1 routers will establish neighbor relationship with level 1 routers, or level 1 routers will establish relationship with level 1, 2 routers. Okay. So another rule is that, or otherwise, we have level 2 routers can establish neighbor relationship with other level 2 routers and level 1, 2 routers. Rule number 2, level 1 routers must have the same area IDs. Remember we said level 1 routers are used in non-backbone areas. So they have to have the same area IDs. Level 2s and level 1 2s can have multiple area IDs. Rule number 3, network types of an ISIS interface on both ends of an ISIS link must be the same. So we have two routers, router A and router B, and they are connected together. You need to ensure that the network type on both sides has been configured the same. So if you have chosen broadcast network, you ensure that on router A, you configure the network type as a broadcast, and on router B, you configure the network type as a broadcast. Network type has to be the same. So we have said that ISIS runs on the data link layer as well as the network layer. So earlier it was designed for data layer alone. So therefore, the establishment of ISIS relationship is not related to IP addresses. Is something that you need to note. The establishment of ISIS neighbor relationship is not related to IP addresses. In OSPF, it is related to IP addresses, okay? But here, at ISIS, the establishment of neighbor relationship is not related to IP addresses. So when ISIS runs over IP, ISIS needs to check the IP address of its neighbor. So if a secondary IP address is assigned on the interfaces, the router can set up an ISIS neighbor relationship as long as either the primary or secondary IP address is on the same network segment of the local. Okay. Yeah. No. It's not wireless. Connectionless means we don't need to negotiate before we start communicating. Connection oriented means we have to negotiate before communicating. Okay. So, for instance, there are those telephone systems that are used by, there are those traditional ones that are used by security guards, not by walkie talkies. Well, I don't know. I think so. Kila mtu ameshaona these gadgets. Okay. First, we negotiate before communication, meaning, I've seen some guys holding them very close to their head so that they can listen to activity. Okay. Yeah. Without having to negotiate negotiate the link. That's what we're calling connectionless. So that's a beautiful feature in that you don't have to rely on connection-oriented communication. For example, TCP at the transport layer is I just want to see your mobile phone. Okay. Just in case you know, you'll not see mobile. Okay, so when you're making a phone call over here, I'm sure everyone has seen this button, unless you come from the moon. Now, we normally say that the phone is on hook. Hook. Now, there's a technical term that we use in telephone. There's a voice. This area where this phone is connected will know that you are about to make a phone call. Okay, before you even dial antennas, kubo kubo the Safaricom, they will know that you are about to make a call. Okay, so at this point, we normally say the phone is on hook. Traffic from this phone to these guys, you have to establish the connection first. When you press some numbers here, you dial the number 07, blah, blah, blah. Okay, not answer immediately. The first thing that they will hear is a beep. It's going to beep. On the side, you're going to hear a beep at the end. So that's what we call connection oriented. Connectionness means I just and then I establish a connection. Okay, that's what ISIS is trying to tell us here. So when ISIS runs on IP, that's when now ISIS checks the IP address. So we have said that we can configure two IP addresses, primary and configure the primary IP. The second one is configured as the secondary IP. So if the two link, we can establish an ISIS communication. Lastly, the ISIS hello packets are used to set up and maintain neighbor relationships. So after we establish a neighbor relationship in an ISIS, we first exchange hello packets. And now, hello packets operate differently from, they operate similarly. Sorry, they is just to sustain, they is to establish a neighbor relationship and sustain it rather than maintain it. So once the ISIS network is stable, routers will still send hello at a period of time, or rather an interval of time. So this is to ensure that neighbor has two-way handshake mechanism. So this one is used to establish the neighbor relationship where after a router declares the neighbor relationship status as up and establishes a neighbor relationship. Then the neighbor does the same way, sends an and declares that the neighbor relationship status is also up, and then establishes a neighbor relationship. So the two-way handshake mechanism sometimes comes with different to devices. I'm not going to discuss Cisco default. So in this mode, 3 point-to-point IIH, that is a hello packets are sent to establish neighbor relationship. The third one is really used for acknowledgement purposes. Okay, so remember the two-way does not provide for acknowledgement, which is a core factor. So here at Huawei, we do three-way handshake. Elsewhere, it's two-way handshake. I should have shown you how to establish network on a broadcast. I think I skipped that slide. But on a broadcast is also three-way handshake. Okay. Yeah, let's look at route calculation on a level 1 router. It's going to come out some. Oops, it's not there. Okay. Let's look at route calculation on a level 1 router. Remember we said level 1 routers maintain level 1 LSDB. A level 1 router will maintain a level 1 LSDB, link state database. Now, there's something about link state databases that we mentioned in OSPF. We said they are the basis for SPF calculations, shortest path fast. Okay, so for us to be able to perform those calculations for shortest path fast, we have to maintain a link state database. We have to maintain a link state database. Okay, so level 1 maintains a level 1 LSDB. And I've said LSDBs are the basis for SPF calculations. So once we perform SPF calculations, that's when we generate routing tables. So remember that logic and that process. So similarly here on ISIS, we maintain LSDBs, but these LSDBs have different levels depending on the type of router. So a level 1 router, we have said maintains a level 1 LSDB. So LSDBs contain level 1, these LSDBs contain level 1 LSPs, that is a link state PDUs, which are generated by a level 1 router. Okay. So a level 1 router will calculate the topology based on the area ID that is provided. For example, here we have given the area ID is that for this side, for this area. So we calculate based on that area ID. Okay. So after we calculate, we set now what we call the just a minute. Let me respond to someone here. One minute. Okay, thank you. All right, so saying once we perform the calculation on the topology based on the area, I've shown you the area IDs here. Each area will have its own unique area ID. These routers that are in this area will set what we call the attached bit or the attached field, which is like a flag, which indicates whether a router is connected to the level 2 or maybe level 1, 2, right? So we set the attached field, right? The attached field means that we are pointing to where traffic needs to be sent, or maybe the traffic where traffic is destined. Okay. So we update the field. We usually set it as either as a 1 or a 0. We're going to discuss that in details when we'll be doing the certification training. So in a level 1 LSP, then they send their area to announce that they can reach certain areas through themselves, or rather through the routers within this area. So as a level 1 router, for example here, router 1 will calculate the default route to router 2 and also router 3 in order to provide the forwarding. So this will be based on the attached field, which we set it as a 0 or we set it as a 1. So when we set it as a 1, we mean that the router is either a level 1 or level 1 or level 2 router, or rather it has a connectivity to other routers like level 1, 2. When you set it as a 0, it means that the router cannot connect to the level 1, 2. Okay, so we usually set it as 1 or 0, the attached field, and it indicates whether we can forward. So you can see it's indicated here as 1. So 1 means that we can reach, or that we are destined for this particular area. Now, level 1 routers usually have what we call the suboptimal path problem. Suboptimal means that we do not have, suboptimal means that we have a situation where traffic is not able to take the best possible route between the source and the destination. Okay. Yeah. So for instance, looking at this topology that we have here, we have the cost has been defined as 10 all through. This is the cost of the link. So level 1 routers may have this problem where we are forwarding traffic in the wrong path, in a suboptimal path. In other words, in a path which is not the best for forward. For instance, let's use cost as the unit of comparison. So from, let me have a pointer. So if we are to use cost as a unit for comparison, we can compare these routes. For us to get to this network here, the 192.168.20.0, there are two paths from router 1, which is a level 1 router. You can either pass through this path here and get here, or we can get from here to this router and to this router. Okay. So looking at this diagram, or rather this topology, you can see clearly that this path is the most optimal. Why? Because it has a smaller cost value. This path, which is in red, has a 10 plus 10 plus 10 plus 10, which is a 40. Okay. And the other one has a 10 plus 10 plus 10, which is a 30. This path is the shortest path. It's the most optimal. Let me use that word. Most optimal. Technically, we refer to that as the path that has the lowest cost and the most optimal. So sometimes during communication, level one routers may result in sending traffic in an suboptimal path. Okay. So later we're going to discuss some of the issues and how we can be able to rectify them. Okay. Yeah. Let's just look at another concept which is found on ISIS, and that is route leaking. Route leaking. Route leaking. And before we get to it, I'll give a scenario. Now, by default, a level 1 2 router does not advertise the routes to other areas, that is of other areas to a level 1. Say level 2 routers are routers that are in the backbone area. And to connect a backbone area router, like level 2 router to a level 1 router, which is an unbackbone router, traffic has to pass through the level 1 2 router. Okay. Yeah. So level 1 routers do not learn about level 2 routes directly. So the forwarding by default uses the default route. So a level 1 router here, when it intends to send traffic to a level 2, it will send through the default route. But if you want to advertise a route directly here from level 2 to level 1, then you need to perform what you call route leaking. So in other words, before route leaking, if you check the routing table of router 1, you won't be able to see level 2 routes there. They won't appear there. Okay. But now, if you want to leak a particular route, which is in the level 2 side, to the level 1 side, we perform what you call route leaking. So route leaking is the process of injecting, let me use the word injecting, a level 2 route into a level 1 area. Okay. So let's look at how we configure route leaking. So route leaking is configured in the following manner. We have said it's a process of advertising routes that are in the level 2 side of the network, rather in the backbone area, to a level 1 side. Okay. So you can do it like this. For example, on this router here, you can configure what you call an IP prefix. Now, an IP prefix is a tool that is used to identify certain packets within our network, IP network. It works similarly with another tool which we call SEL. SEL. So SELs and IP prefixes are tools that we use when filtering, especially routing information, or filtering certain packets within our network. An SEL filters packets based on the based on the IP address alone. In other words, it checks for packets that meet certain criteria based on the IP address. It differs from an IP prefix in that an IP prefix filters traffic based on both the IP address and the mask length. Okay, so when you're configuring an IP prefix to filter certain packets within a network, it will be inspecting for both the network address and the mask length that is defined on these packets. But for SELs, they only check the IP address. They don't check the mask length. Now let's look at where they are used. Okay, so SELs are rarely used, especially when you want to block traffic. We want to block packets from getting to certain destinations. You can configure an SEL to really work perfectly for providing switch hardening, you want to harden your switches so that VLAN information is not moving from one side to the other. Okay, so you can control inter-VLAN communication using SCLs. Okay, and you can also filter certain packets that are destined to certain protocols within the network. But for IP prefixes which have more filtering capabilities, rather, they're more specific in that they check both the IP address and the mask. They're ideal, especially when you're doing routing. So when you're performing route filtering, then IP prefixes coming into play. I want you to go and read more of the two IP prefixes and SELs and how we apply them at different scenarios. Okay. So here, since we are performing route leaking and we want now to leak certain routes into certain areas of the ISIS domain, we are going to use an IP prefix. So this is the syntax of configuring an IP prefix. You use the command IP followed by the keyword IP prefix. Okay. Then followed by a name. You can use a name here, or you can just have a number. So you can put a name describing maybe your IP prefix, what is doing, or you can have it as a number here. Then it will have the action. So the actions are normally two, either it's permit or deny. So here we're going to talk of a permit action. Then we're going to specify the IP prefix here and the mask length. Okay, yeah, the mask length. Okay, yes. Then after that, we are going to configure ISIS. This is the procedure of configuring ISIS. We say ISIS process ID is number one. Then inside the ISIS view, we type the command import -route ISIS. We are importing ISIS routes. Okay. Then we specify is level 2 into level 1. Then you put the filter policy. These are keyword policy IP prefix. Then the name of the IP prefix which we had created here is 1. Okay. So this way you'll be filtering level 2 routes into level 1 side. Okay. Yeah. So this is done. Route leaking is done on a level 1, 2 router. Yeah, you do route filtering or route leaking on a level 1, 2 router. Okay. Yeah. Then you do it also for this side of the network. Now let's look at another concept of ISIS, and that is ISIS authentication types. ISIS authentication types. So ISIS packets also can be encrypted, just like we saw with OSPF. So ISIS here supports 3 authentication modes. We have the interface authentication mode, we have the area authentication mode, and we have the routing domain authentication mode. Okay. So for the interface authentication mode, this one interface authentication targets certain packets. In that, to be specific, hello packets are the ones that are targeted by interface authentication. So if you configure ISIS authentication on the interfaces, you'll be targeting the hello packets. Are we together? Now, for area authentication on ISIS, this one is implemented in the ISIS process. There's a difference between interface view and ISIS process view. Are we together? Yeah, so the interface view means you have selected the interface that is participating in an ISIS network communication. And then on that interface, you configure authentication. Let me demonstrate this very fast. Let me demonstrate this so that you can sure to differentiate the two. Okay, we have a topology here, which is defining ISIS communication between two areas. You can see we have area 49002 and area 490001. I'm going to start it. I'm going to start the routers that are involved here. Let's give it a second. Then I'm going to rearrange my screen a little bit so that you see. I want to assume the routers are not configured with any configuration. So to see the configuration, say display current configuration. Let me just scroll through. There are no configurations. So allow me to just plug them the right configuration first. Allow me to just have these configurations very fast. Then I have router 2. And I have router 5. In router 5, we have a static route. Let us assume that is an external. And lastly, we're not going to do this labs because of time, but I just want to get the logic. Okay. Yeah. I'm going to configure router 1 for ISIS. So this config ISIS. And router 5. So router 1 to 5 all running ISIS. Yep. I want to show you something. So on router 1, I'm going to clear this so that it fits on the top. So I'm going to display ISIS interfaces. So these are the interfaces that are participating in our ISIS network. Shown here. Okay. Yeah. So these are the interfaces. So I want to show you, for example, the configuration for ISIS, CC ISIS, and that is the configuration. So when you're configuring a router, you specify the level. So you say IS level, then you specify the level 1 or level 1, 2, or the level 2 router. Okay. Then you specify the costs. You normally have cost styles. So for cost style, you say, for example, we have two cost styles. These are the cost styles that we have. I forgot to mention in my slides. In case you asked in the exam, these are the cost styles that we have. So we have wide, which is the most common. We have wide compatible. We have narrow and narrow compatible. And we also have compatible. kindly capture this somewhere in your notes. After that, types of cost styles. Let me capture it. Um, okay. Captured it. I just wanted to update my notes. Right, so those are the cost styles that we have. So these are level one router. Uh, let's look at a level 1, 2 router, like router 2 here. See how it has been configured too as well. So display CC ISIS on this one. Now you'll notice here it's not indicating the level. Okay, you can see it's indicating level 1, 2. It's because by default, this one put it somewhere. By default, all routers before configurations are level 1, 2. So the moment you enable ISIS with this command here, our router will be a level 1, 2 by default. Check router 3. Let me clear this one. So router 3 is said place CC ISIS. You can see also this router here, we have not defined because it's the default. The default is a level 1, 2. Now for this other router that is on this edge, that is router 4, you will notice that this one you have to specify display CC ISIS. Okay, so you have to mention that here in that command. Okay, great. So we're looking at authentication, interface authentication. So for internet interface authentication, we have these 3 examples here. We have said you can configure it on the interface directly. So for instance, for router 2, we can have that command there. I'll explain it. So first thing, you select the interface. Okay, so if you display this on that interface, you'll notice that it's indicated as we have the IP address. Then you enable ISIS on that interface. It's a command that is used to enable ISIS process on the interface. Then you can see the authentication. It starts with ISIS authentication -mode MD5. And then you specify the password. You have seen the password you put Huawei. Okay, so you can do that for that. And router 3 can also have the same. This one. Do the same. So you display this, you'll be able to see the other similar. So once you do MD5, it encrypts the password. You won't be able to see the password that is there. Okay. Yeah. But you have also said you can authenticate the process. So for instance, let me pick an example of this router 3 displays CC ISIS. You can see the process here. So if you have to go to the process itself, this is the process ISIS1. You can say we call it domain authentication. This I was looking for this command here. Domain authentication mode. Then you can specify the domain authentication is MD5. Then you put a password. Maybe you say Huawei. Okay, but you have to ensure that all the routers that are in that domain have been configured with the same password. Let me go back. So we have domain authentication, which is also configured on the ISIS view. Okay, on the ISIS view, we also configure that. Now, domain authentication targets the complete sequence number PDUs, partial sequence number PDUs, and LSPs. Area authentication targets the CNSPs as well as partial sequence number PDUs and LSPs. Okay, yeah. Sorry, I was on live call. I forgot to unmute. All right. So the methods that we have for authentication include clear text authentication. We have MD5 authentication, keychain authentication, and HMAC SHA-256 authentication. These ones are the ones that are supported in the three. Okay. Yeah. So I would like us to take our early break, and then now we meet at 2 p.m. Okay. Yeah. Let's take our break. So lunch break. Going to resume back at 2.